All right, so we're going to do 1.4 is what we're going to finish. Somebody tell me the last slide we stopped at. What slide did I stop at? 16? All right, let me go back to it. All righty. So just to make sure, we're talking about creating lines. Remember, we talked about creating a line. Do you remember we talked about the blood alcohol percent? Yeah, we did that conversation. Did I also tell you that there are three types of equations that three situations for creating linear equations? What was the first type? Type 1. A point and a what? You're going to have a point and a slope. Okay, what's type 2? 2 points. And what's the type 3 situation? You got a point and an equation. And so I gave you the steps for how you are to create your y equals mx plus b equation based upon what type of situation you are given in the homework, right? All right, what's on the screen? What type is this? Type 2. You got 2 points. In the homework, there was one question where they're going to give you this. It's going to say intercept is 3, the y-intercept is 3, and the x-intercept is 4. What type is that?
What you say now?
Okay, in the homework, they're going to give you a question, and it's going to say, write the equation, and you're going to be like, what? And it's going to say the x-intercept, I'm making this number up, guys. It's going to say the x-intercept is 3, and it's going to say the y-intercept is 4.
That's type 1.
No, that's type 2. That's type 2.
What did they give you? Somebody tell me what they gave you. They gave you 2 points. This is on the graph. Can't you put this point on the graph? Yes. Can't you put that point on the graph? Yes. So they gave you 2 points. So why did they do that? We wanted to make sure that even though I gave you 3 types of situation, they may rewrite how they give you that information. So instead of just saying they gave you 0, 3 and 0, 4, they rewrote how they gave you the given points. And they assumed that you knew them was 2 points. Okay, so we got it? So it's not always just going to kind of spit it out at you and make sure you got it. Just make sure you understood that these are still 2 points. We're good? So when you see that, you'll know what to do. All righty. So going on, since we already passed all of this, we got past, let's see, I'm trying to make sure you said 15 or 16? 16? Okay. We did equations of horizontal and vertical lines. What's the slope of a horizontal line? 0. What's the slope of a vertical line? Undefined. There is no slope. Okay. All righty. Y'all on top of it. All right. What situation is this?
It's type 3.
Type 3 situation.
Because it's a point in the equation.
And a point and an equation. Now, here is the thing about type 3. Type 3 is going to ask you to not only create an equation, but it wants a parallel line. So we're looking for the equation of a parallel line. The next slide is going to ask you for the equation of a perpendicular line. So you got to change the slope with the perpendicular. So let's go ahead and walk through this one really so we make sure we're on the same page. All right. What were the steps that I gave you for type 1, 2, and 3? Did I give you steps for type 3?
Yes.
All right. What's step 1? I need to figure out what the slope is. Okay, so I need to calculate the slope. I'm going to say determine the slope. All righty. Well, how am I going to determine the slope? They gave me a point and an equation. Solve for y. Thank you. Get y by itself. So I have the equation 5x minus 2y is equal to 8. What you want me to do to get y by itself? I subtract 5x from both sides. Divide both. So hold on. Let me see. This cancels. The net 5 minus 5x is going to cancel out. I end up with negative 2y equals. What should I write first? The minus 5x or the 8? Why? Because I'm trying to get it to look like y equals mx plus b. So I'm always going to write this part first. Wherever the x is, I'm going to leave it attached to the variable. Alrighty, so with that said, divide everything on both sides by? Alrighty. So y is equal to 5 over 2x minus 4. Done. Now, is that the answer? No. We just rewrote the first equation that they gave us in order to find the slope. So what's the slope?
5/2.
So now I know my slope is equal to 5/2. And the next step says, now that you know what the slope is, what am I supposed to do? Step 2.
Find the wider, find the parallel.
Did I give y'all step 2?
No, you're not. After that, we just stopped at that.
We just stop here. All right, so step 2. Now that you have the slope, do I keep the slope the same? Yes. So here's your hint. Your hint is for parallel lines, slopes are the same. Slopes are the same. So do I need to change the slope?
No.
No. So we're going to keep the slope like it is. So now I'm going to do step 2, which says to plug in what? X, Y, and M into what equation? Y equals mx plus b. Alrighty, so do I know those 3 numbers? Yes. Did they give me an X and a Y? Yes, they did. Alrighty, so I've got enough X and Y information to go ahead and plug it in. So here is Y equals mx plus b. Alrighty, so I'm going to plug a m in, which you told me m was what? 5/2. And the x and the y, what's x? What's the x point from the order period they gave us? -2 goes here. And what was y? Alright. So now I have a fraction and a whole number that an integer that I'm multiplying together. Can I put a 1 underneath it? Yes. Do I have to? No, you don't. I'm just going to kind of keep it simple. I'm going to put a 1 underneath here and multiply straight across the top and straight across the bottom. So now I have 5 times -2, which is? -10 divided by 2. What's -10 divided by 2? -5. What are we trying to get by itself? B.
So add 5.
Add 5 to both sides. Alrighty, so now these 5's cancel out. I end up with B equals 8. Do I have enough information to write the equation of the parallel line? Yes. What's the final equation? Okay, so I use my same slope because I'm trying to write it in y equals mx plus b form. So I'm going to use my 5/2 because I already defined my slope. X always stays x. And what was my y-intercept that we just figured out? 8. Okay. We have the same answer that they have on the side. All right, any questions? I didn't give y'all the sign-in sheet, did I?
No.
All right, here it is. Okay, it is 5:31. There you go. All right, so guess what the next slide is going to ask me to do? I want the perpendicular equation. So in order to find the perpendicular, there's only one small change. I'm just going to change the slope. I'm going to flip the slope upside down and change the sign. So I need a new slope. Alrighty? So we need a new slope. Let me go ahead and move this side of the board. So on the new slope, here's what I want to do. So I've got my old slope, which is equal to 5/2. So what's my new slope again, guys?
-2/5.
Okay, so -2/5. Hint, flip, and change the sign. Alrighty, so back to my y equals mx plus b, because you're just trying to write an equation. This was my parallel line. Over here, we're finding our perpendicular line. Alrighty, so. Alrighty, can I plug my slope in?
Yes.
Yeah, I'm gonna put my -2 this. I'm gonna use my x and my y that they already gave us from the original problem. So we had, what was that, -2 and a 3? -2 goes here, 3 goes here, and solve and get b by itself. I'm gonna go put a 1 underneath it to create my fraction again. And I'm gonna still multiply across the top and across the bottom. I end up with 4 over 5 plus b. What do I need to do to solve and get b by itself? Subtract 4/5 from both sides. And I end up with b is equal to, I don't know yet because I have some fraction math to do. So it's going to be 11/5. Do you remember how to add fractions and whole numbers? You do? Just in case, put a 1 underneath it, find a least common denominator, which happens to be 5. So make sure that both of your denominators are 5. What do I multiply 1 by to get 5? 5. Alrighty. So here is 5. So now I end up with what? 15 plus 4 over 5, which is that right? What's wrong with my math? What's wrong, y'all? Tell me what's wrong, because y'all know there's a mistake up there. Where's my mistake? I'm expecting y'all to catch my mistakes when I'm making mistakes. My disclaimer is I am going to make some mistakes while I'm up here. So, where's my mistake in here? I should be subtracting and not adding. All right, so with that said, 15 minus 4 is how much? 11. All right, so we go over here, and can I write my final equation? Yes. Y equals? Okay, y equals -2/5 x plus 11 over 5. That is your perpendicular equation. Questions? Okay. That means y'all good? Okay. Of course, so it's the same solution we have here. Scrolling to the next one. There's a general equation, which you can call it general or standard form, which you have ax plus b. Here's an example of what we call a general or standard linear equation. And it just basically looks like this. So if I say 2x plus 3y equals 5, that's called general or standard form. Usually the x and the y are on the same side of the equal sign. When you have an equation, linear equation, both x and y are on the same side of the equal sign. I call that general or standard form. Then, of course, you've got point slope, which we already have used, but we're not going to use it since you like the y equals mx plus b better. Alrighty, we know about y equals mx plus b, which is a slope-intercept form. We talked about how to create a vertical line and a horizontal line, right? Did you forget or you remember? You remember how to create a vertical line? Okay, so if I have a point, just checking, just to make sure you're okay with this. Here's my x and y axis. 1, 2, 3. Here is my horizontal line. Let me make it a different color. Hold on. Here is my horizontal line. What's the equation for the horizontal line? Oh. What's the equation of the horizontal line? Is it x equals 3?
It's y equals 3.
It's y equals 3. Why is it y?
Because it's on the y.
It crosses the y-axis. Okay, so whatever axis it crosses and where it crosses is the answer. What if I give you a point and say, what is the horizontal line for that point? So what if my point is 1, 3? And I say, put a point on 1, 3, and that would be right here. And I say, tell me what the equation of that horizontal line is. And I only gave you 1 point. Y equals 3. All you need to know is what the y value is. What if I give you a point and I say, what's the equation of the vertical line? And here's my point, 2, 5. That's my point, and I say, what's the equation of the vertical line that passes through that point? X equals 2. That's it. Don't make it difficult. Alrighty, let's see. Alrighty, average rate of change. This sometimes can be a little bit like, okay, what in the world are they asking me to do? So I'm going to jump to the next slide because I need you to make sure you see the connection between what's written on this screen and what's on the next slide. The average rate of change is very much like the slope. Only thing is you're going to be given 2 x values that you have to plug in. to come up with your y value. In order to do the slope formula, what do you need? You have x1, y1, and you gotta find the slope. What you need? X1, y1, and
Y1, and Y2.
okay, you gotta have 2 points, right?
Yeah, Y2 minus Y1.
So again, if I need both of these, this is x1, y1, and x2, y2. I need 2 points in order to calculate the slope, which is similar to the average rate of change. So when you see average rate of change, you really are still doing pretty much the slope. It's written in a different format because they want you to plug in the numbers they give you. So let's look at the next slide. All right, we're going to talk about that as soon as I get to the bottom of the second half of this. So let's just kind of get into the conversation for how we're going to talk about the slide previously. All righty, the sales and projected sales of the electric-powered Tesla, which is my favorite dream car of all cars. Okay, and the number of Tesla sales can be modeled by the function you see. Why did they choose the letter variable S? Sales, okay. And T is referencing time. So you have a function where S of T is in thousands and T is the number of years after 2010. We got it? Right now you're just looking at a graph of the equations using the data that they gave us. So again, we're looking at, hey, for 2 years, this was the sales. For 3 years, this was the sales. 4 years, and it's just charted in a bar chart, and over here is in a curved or line graph. We just wanted to know if you actually plug this into what? What graphing tool are we using? If you plug it into decimals, you should get a curve that looks similar to this. Okay? You okay so far? Question is, do you understand the conversation? What's the topic? Sales of the Tesla. For what? What's my X, or what's my input that we're talking about? Years. So you got a year and how many Teslas sold. You got a year and how many Teslas were sold. And a year and how many Teslas sold. So again, we're okay with that conversation. Input is your year. Output is the sales. Okay, number of sales. All right, here we go. It says find the average rate of change. When you see the word rate of change, what should pop into your mind? Slope should pop into your mind. It wants you to find the average rate of change of sales. S of T is always sales of the Teslas when T is equal to 2 and T equal to 6. Well, wait, what is T again? Time. When? When is it? 2 years after 2000. What was my beginning year on the previous slide? 2010. So this 2 that you see is 2 years after 2010, which is 2012. And then the other number they gave us is T equal to 6, which is 6 years after 2010, which is 2016. So they want to know from 2012 to 2016, what's the average rate of change in the sales for Teslas? You understand the conversation? Okay, so with that said, I had to plug in a 2 and plug in a 6. So where you see S, that's not S times 6. That's S of 6, which means you plugged in a 6 in where? Where'd you plug that 6 in? Where the T was in the original equation on the previous slide. So when you plugged in S of 6, when you plugged in 6, what number did we get? 98.28. When we plugged in 2, what did we get? 1.896.
How did I get 99.2?
When you plug it into the previous slide. See that equation right there?
That 3.5 to 1.
So everywhere you see a T, what number did we plug in? A 6, and then we went back and plugged in a 2. Once you do that, you get these 2 numbers that you see here. You should get this one and this one. Are these Y values, guys? Say yes. Yes, they are. Yes, they are. They are Y values just like the slope. Remember, you'd have a Y2 and a Y1 and an X2 and an X1? Wasn't this output? Isn't this the output? When you plug in a 6, we got out 99.28. When we plugged in a 2, we got out 1.896. So you did get output. So output is on top, input is on the bottom, and then we just did the math. So you got for 99 minus 28, excuse me, 99.28 minus 1.896 give us 97.384. Divide that by 4, and we have 24.346. What in the world does that mean?
24,000.
Okay, so it is 24,000. What about it? Tell me what that number means. When it says in the homework, interpret, it wants to make sure you got an answer. Now, do you know what that number means?
Each year went up by 24,000.
And why are you saying that?
Because it said the average.
It said the average what?
And then it says increase.
The average what? What was the word?
Yeah.
The average what? What word is the average what?
Rate of change.
The average rate of change. And was the rate of change positive or negative?
Positive.
So you knew it went what? Up. So from 2012 to 2016, the average rate of change went up how much? 24.346. And is this just 24? Is this just 24 sales? No, this is in the thousands. Go back and look at the previous. Let's see if I had it right on the previous slide. Somewhere in it says the thousands. Over here, notice it's referencing it in thousands. So again, paging back down, this is 24.346 thousand. Tesla's the increase in sales have been 24.346 thousand per year. Why do you think that's so? Just out of curiosity. I mean, I love the car, but why do you think it's increasing? People like electric cars because it is electric.
Oh, because it's used,
It don't use no gas since gas is going up.
because they be using it in videos and all that type of stuff. People
so-
money when Tesla.
Okay, just out of curiosity, it has nothing to do with what we're talking about. I'm just curious to see if you had any thoughts about why it increased. And do you think it's going to continue to increase?
I don't know, because they're professional fire killing people, so I don't know.
You don't think that we're moving away from putting gas in our cars to electric cars?
Now they will, it increase.
We'll find out in a couple of years, right? Okay. All righty. Question. All righty. Here's the next slide. Suppose a ball is thrown straight upward. Oh, question. I'm sorry. Go ahead, Tina.
So can you go back? The 99.28 and the 1.896 is from.
You plug it in this number. Plug it into the equation.
Okay.
So if you plug the 6 into the original equation, you're going to get that number. And plug the 2 into the original equation, you're going to get this number. Were you thinking did she go someplace else?
When you put it in calculator and you didn't get that?
That just means that somewhere we ain't put it in the calculator right.
Yeah.
Other than that, now let me change that. There could be a typo on my slide, so that is quite possible. There could be a typo on my slide, but it should come out to be that number. So we can check the math and see, did anybody else actually plug those numbers in? Somebody plug it into the calculator well, and the reason why I say that because you have to be able to do this in your calculator. You do know that, right?
Yeah.
And you have to be able to put it in your calculator correctly. So somebody plug in a 2 and a 6 into these and see what answer they get. You got to cube it. Anybody else need to sign in on the sign-in sheet? No? Okay, we're good. The reason why it's actually a good idea for you to do this is because sometimes you'll be in here and I will have said all of this and you get home and be like, that did not come out right. So it's a good idea for you to actually figure out and see if you see anything that you didn't do right in here while you're in here with me. What happened? Y'all still typing it in?
Yeah, it's right.
I did it with
Did you get,
6Q, right?
yes.
And I got like 760.5.
It's because we didn't put the 6 and then back to the third power in parentheses.
Remember what we said about it's all about how you put it in your calculator. Did you put when you put the 6 raised to the third power, did you put the 6 in parentheses and raise it to the third power?
You gotta put both of that in parentheses.
Same thing with the t squared. Did you put it in parentheses raised to the power?
I need a calculator for us.
Oh.
You missed one thing.
All right, so before, let me go to it actually in one of my, you still didn't, it didn't come up right? Oh, okay, hold on. Here's the web calculator that I use, web2.0calc.com. Somebody read it to me. Read the equation to me. Okay, so I'm putting in the 6 raised to the 3rd power. Okay, what else?
Like that.
Okay. 149. Okay, y'all know what I just did wrong. Y'all see what I'm doing wrong, right?
Yeah.
Pick a 6, pick a 2, but don't do both of them at the same time. All right, let me go back and change. This should be, I'm gonna do 6. That was the 6. Because again, I've got to do both of them. All righty. All right, what's the rest of it? Four. Is that it?
Oh, you did the whole problem.
That's for the 6. Okay, I can do it back too. Okay, so you do. We are sure that the 6 works. Okay, here, let me go back and do it with the 2. I'm just gonna put the equation back in so I don't have to type it. I'm gonna change all my 6's to 2's. All righty, here we go with the 2's. Done. So that means somewhere in your calculator it's not being put in there right. So you should put it in there like you see I have mine. Notice what I have in parentheses? The numbers that got raised to powers, I put them in parentheses. Questions? Tila, did it come out right this time? Are you putting yours in like mine? It's easy to make a mistake, guys. Y'all see I'm making them up here. I got you. Okay, so we do know that that slide is okay. All right. Let's see, where am I? 1.4. All righty. So now we can go on to the next one. All right. Suppose a ball is thrown straight up in the air at 64 feet per second, and the equation that gives the height of the ball t seconds after it is shot is f of t equals 64t minus 16t squared. Find the average speed, which is the average rate of change of the height per second of the ball over the time interval t is 1 and t is 2. What you gonna do? The exact same thing we just did. You got a different equation. T is 1 and t is 2. What was t in the previous slide? T was 2 and 6. Now t is 1 and 2, and you got a different equation. So, with that said, here is the next slide. Now, I did some extra here that you didn't have to do. I actually, when you plug in f of 2, I end up doing the 2 times 64 is 128. And then 2 raised to the 2 power times 16 is 64. So all of this part right here is f of 2. This part over here is f of 1. When you plugged in a 1, I plug in a 1. So 1 times 64 is 64. And up here, 16 times 1 squared ends up being 16. So I have 64 minus 16. And when you do the math in both parentheses, you end up with 16. Now, of course, that's doing it by hand. You should be able to do that straight from your calculator without actually doing all what you see, what I did here.
So we don't have this slide, huh?
Y'all don't have that slide?
It's 29.
Oh, then so let me make that change. When I go back through these slides, when I'm actually going through and figuring out, you know, how I want to say certain things, if I need to make changes to a slide, I'll make changes to a slide. So if y'all see the slide and be like, that ain't what that slide says, I may have made a change to it, and then I just hadn't sent y'all the, or I may have deleted a slide. Like I'm like, okay, that slide wasn't necessary. So I may have deleted a slide that wasn't necessary. So if you see that, just know I took that slide out. Okay, so with that said, what does it mean? You got the answer 16. What does it mean? 16 what? What does that mean? That the ball average rate of change, which is the same thing in this case as the speed of the ball, is 16 feet per second. Okay, so let's put it back in more practical terms. Most of us don't play baseball, right? Okay, so you drive into Charlotte, and you start off driving 45 miles per hour. Maybe you just kind of not feeling it that day at that point. And then by the time you get out, well, maybe it took you a little bit to get out of Atlanta, because you know how getting out of Atlanta sometimes can take you some time. So you're traveling 45 miles an hour just to get to outside of the Atlanta metro. Then you can pick up your speed and you're driving now 70 miles per hour. What's the average rate of change of your speed? That's what we just did. What speed did you start at? So the first hour, you started out at your first hour, you went 45 miles per hour. Second hour, we were able to get up to what? 70 miles per hour. How do I find my average rate of change or my average speed on my way to Charlotte? So I'm going to do just what we did up here. 70 minus 45 over what? So these are my ordered pairs. 2 minus 1. And that should be a minus sign. All righty, do the math. What's 70 minus 45? 35. And what's 2 minus 1? 1. So what was my average rate of change for my speed? About 35 miles increase. That was a positive, right? It was positive 35. So my speed increased by a positive 35 miles per hour. Same thing. We're talking about speed of a car versus speed of a baseball. Does that make sense? Yeah. Okay. Next one. All righty. So let's see what this conversation is. All right. Let's see what the conversation is. The table and the figure that's in the next slide is going to show real and projected enrollment in the thousands at U.S. public schools for selected years from 1980 to 2024. Okay? So you can see the sources from the National Center for Educational Statistics. All right, it says create a scatter plot for the data. What does that mean? Graphic. Where are you going to put these points? On a graph. In what tool? Desmos. In this case, you're using Desmos. So whenever you see in the homework it says create a scatter plot, you literally go to Desmos. Where do you go to put those points in Desmos?
The table.
The table. How you get the table to pop up?
It's on the left-hand side.
Hit the what at the left-hand side?
Like
The plus sign. Hit the plus sign at the left-hand side at the top, and it'll pop open a window where you can pick table. All right, so when it says create a scatter plot, just put the numbers in the table. Notice the next question. It says, does a line fit the data? Now, what they're asking you here is, if you have some data and you can put it in Desmos, does the data look like it's the shape of a line?
No.
And we won't know that till we put it into the graphing tool. So, if you have a table of X, Y axis here, and my data looks like this, does it kind of mimic a straight line? Kinda. So that's what they're asking you. When you see the data in Desmos, does it almost look like it could be the shape of a straight line? Does it mimic the shape of a straight line? If it does, then you can answer yes. That line looks like if data fits a straight line. All right, average rate of change. Did we not just do the average rate of change? All right, did they give me some input values? Of course they did. They want the average rate of change of high school enrollment from 1980 and the projected 2024. And then it wants you to do what? Well, it wants you to write the equation determined by, you got your rate of change, which is the same thing as the slope. And then we're going to need a B value, right? So we can go back and do what we already learned how to do. So we're going to do all of this. So let me go to the next slide. All right, go put your data in Desmos for me, please. That means you need to go to Desmos and literally type those things in Desmos for me, please. Y'all know how to get to Desmos? Y'all good? DESMOS.com. DESMOS.com. Click Start Graphing. Pick your plus sign at the top left. and type those in. Nicolette, I'm gonna go up to my office when we get done and see if I left that copy of the book on my desk in my office, because I should have a copy in my office, because I thought about it today, and it was immediately when I thought about it, I should have grabbed it. You know, I was like, oh. Let me know when you got them typed in. What's wrong if you can't see anything on your screen? Okay, you gotta change your window this way and this way. You got them typed in? Or y'all still typing? Okay. And you don't need the commas. Guys, you see where you see commas in the 41,000? You do not need the commas. Can you see the graph of the knot points? You should see all of your points on the screen. How many still typing points? I'm gonna need me some gloves and mittens in here in a minute. Let me see what the next slide looks like. Does your points look like that?
Yes.
From the previous one, yes, you could decide how high. Yeah, I would have made mine go from, again, it went from 0 to 60,000 on your y-axis. Now you got your points all in? Okay, so this is what your slide should look like. Your points should look something like mine. That's your scatter plot. Do those points kind of sort of look like they're in a straight line? Yeah, kind of sort of. It's not a perfect line, right? It's not meant to be perfect at this point. The question is, does it kind of sort of look like it can mimic a straight line? So that's what you're looking for, to see if there's a linear function that can approximately model the data that we had from your XY table. If it does, then we can create an equation from it, which you've just been learning how to do. Then you learn how to create an equation? I gave you 3 situations, type 1, type 2, and type 3 for creating equations for data. So this is the situation that you have. Here is, if I want to find the average rate of change, that's going to help me find the slope. So you didn't even have to plug anything in an equation, did you? In 1980, high school, and what was high school enrollment?
41,000.
Okay, there shouldn't be 2 commas here, because I don't want you to confuse and thinking there doesn't need to be a comma here. I'm gonna actually take it out so I don't have it here, so you won't think it's 2 commas needed. Alrighty, and the enrollment projected for 2024? Okay, can you see how I just plop these numbers into the slope formula? And do the math, and it comes out to be, alrighty, 237.8. That's it? 1,000. This is high school enrollment. Is this an increase or a decrease? Increase, because this number is positive. So the average rate of change meaning the enrollment of high schoolers in the United States is on the increase 237,000 per year. Does that make sense? Yeah. We still having to do trailers outside the schools because we have more and more kids coming to schools. So again, this is just enrollment increase for high school. This means that public school enrollments have grown at an average rate of 237.8 thousand per year. Okay. Questions? You're good? It makes sense? Okay. Can I create an equation with this based upon what we just figured out with the slope? We did the average rate of change, which is similar to the slope. So what else do I need in order to create my equation? I need the B value for your y-intercept. So guess what you got to go do? Use your y equals mx plus b. Plug in one of the points. You got a whole lot of points to pick from. Does it matter which points I pick from in my table? No. You can just pick any one of those points from that table. You already know the slope, and we can create our equation. So here is, let me see if I put that on the slide. There it is. So what point did I pick? I picked the 1980, 41,651 is my point. Plugged it in, and look at my equation for that data. That's the line that will come as close to mimicking that data as possible. So again, when you go to draw a line, they're going to call it in the homework the best fit line. Does it mean it'll fit it exactly? No. But if I had these dots were part of my graph, I want the line that comes the closest to all of those points. That's called the best fit line. So in this particular case, based upon the information that we have, we created our average rate of change, which was our slope. We plugged in two other points and did the math using y equals mx plus b, and we came up with that equation. That's the best line we could come up with for that data. Questions? Okay. So you could do this on the homework, right? Say yes. Okay, but that's exactly what you would be doing. Okay? In the next few slides forward, you won't have to create the equation. We'll use a tool that'll actually create the equation for us. You just put the data into the graphic, into a tool, and it'll create it for us. So that's what we'll do in the coming slides. So that is the end of chapter 1. We have completed everything for chapter 1. So with that said, let's take about a 2 or 3 minute, and then I'll start chapter. I usually won't take it, but I just kind of want you guys to breathe for a couple of seconds. And then let's start chapter 2. We're going to go ahead and start on chapter 2 because I want you guys to know that we're trying to finish as much as possible. So take a couple minutes and come right back. So let's just breathe for a second before we start chapter 2. And let me go ahead and pull it up while you guys are doing that. All right, chapter 2 is here. Oh, I didn't rename it. I meant to rename it. I'm gonna go see if since my office is on this floor, I'm gonna go see if I actually have that book in my office.
No, your roll sheet.
Oh,
I did.
who's got the sign-in sheet? Oh, you put it back up here?
But I didn't know if I could put it in there.
I did. Okay, I sure did. Thank you. All right, let me see. This is the fourth, but it's the same. Okay, so 2.1. We're going to talk about algebraic equations, how to solve them, both algebraically and linearly. So, with that said, let's just kind of see. The first slide, we're definitely going to solve them algebraically. That means I want you to do it by hand. And then, of course, I'll show you how to do it using the graphing tool. So, here's the first one. This is just a reminder of what it means when you see linear equation. Here, the first, those first two, a linear equation and one variable, obviously it only has one variable. It's written in the form of, can you see that A and B happen to be numbers in the example that I gave you? So A is 2 and B is 4. Look at the linear equation with two variables, which is AX plus BY equals C. A, B, and C are all numbers. What's A in my example? 3. What's B? And C? 15. So again, that's just the standard form of a linear equation. And of course, just a reminder, you know we always have y equals mx plus b, which is written in two variables. You have a y and an x, just as a reminder. I'm not going to read this because I'm going to walk through how to solve a linear equation in one variable, and then you can go back and read it if you want more details, but I like the way I say it better than just reading it from the screen. So here is the first equation that's algebraic that you're going to solve for x. So when it says solve this algebraic equation, it wants you to get x by itself. Okay? Our goal is to get x by itself. So now in the past, if you guys have seen solving equations before, you know exactly that you've probably seen where it says find the LCD, right? And you're like, okay, yeah, I remember we find the LCD and multiply both sides by something. This is perfectly okay. The method that I use here is usually what you will find being taught most of the time in most textbooks. I'm going to modify it just a little bit. The goal is you don't really want to play with the fractions, do you? No. So let's figure out just the easiest way so that you can get rid of the fractions and then see how comfortable you are. Now, if you say, I'm used to doing it this way, that you see it on the screen and you like it, it's perfectly fine. Use the method. But I'm always going to attempt to show you something that looks simpler to me that we can use, and hopefully it makes you feel a little bit happier about doing fractions. All right, so in the first part here, let me show you my method. I'm going to solve and do the exact same, almost the exact same thing, so you can see how easy this is. The homework will give you an example that's very similar to this one, so that's why I wanted to make sure you had something like this. All right. First of all, everything up here, I'm going to turn it into a fraction. You're like, I thought we were going to get rid of the fractions. We are going to get rid of fractions. But to start off, I need everything to already be a fraction. So how do I turn this number 1 into a fraction? Put a 1 underneath it. Now, I am going to have to find the what? Least common denominator. Now, how do you find the least common denominator? Start multiplying the numbers on the bottom. Now, I know you might have learned it a long time ago. You put 4 and then 4 times 1 and 4 times 2 and 4 times, and you keep on multiplying it out. And then you put 3 and 3 times 1 and 3. I'm not going to do it that way. All right, because that's just too much extra work. All right, so start multiplying the denominators on the bottom. That's where we're going to start. So 4 times 3 is how much? 12. Okay. Now determine if each one of these numbers divide into 12 evenly. Does 4 go into 12 evenly? Yes. Does 3 go into 12 evenly? Yes. Does 1 go into 12 evenly? Yes. Done. There's no more. That's it. You're going to check it for each number that you have on the board. You're going to check it and make sure that each one of these numbers divide into it evenly. You got it? Just start multiplying the numbers on the bottom together. So let me change this just for a second, just to show you that this actually does work out okay. So, for example, I'm going to change it just for a second. I'll put it back because I want you to make sure that this works for you. I have three denominators up here, and I need to see what the least common denominator is, and I'm gonna use still the same rule I did, multiply. 4 times 12 is what? Excuse me, 4 times 3. 4 times 3 is what? 12. All right, let's ask yourself the same question. Does 4 go into 12?
Yes.
Evenly, does 3 go into 12?
Yes.
Does 5 go into 12? No. So 12 ain't the least common denominator. So keep multiplying. We already said 4 times 12, 4 times 3 is 12. 12 times 5 is 60. Does 4 go into 60?
Yes.
Does 5 go into 60?
Yes.
Does 12 go into, excuse me, does 5 go into? Okay, let me stop for a second. I'm just messing up my words now. Alrighty. 60 is my LCD. And 4 divides into 60 evenly, 3 divides into 60 evenly, and 5 divides into 60 evenly. That's your LCD. I'm always going to just multiply till I get a number that each one of these divide into evenly. That's it. You're good?
Yes.
Okay, does that make sense? Keep multiplying until you get a number that all of them divide into evenly. Okay? Well, you might ask the question, well, what if this, I'm changing the bottom again just for sake of explanation. You're like, well, what if that's a 4 and that's a 4? Do you really need to, do we have to multiply? We can, but it's not necessary. If both of these are 4s, I know 4 is going to go into 4, and I know 4 is going to go into 4, but
20.
does 5 go into 4? No. So I'm going to end up multiplying these two numbers together. You don't have to multiply these two if they're the same. You got what I'm saying?
Yeah.
So since these are the same, there's no need to multiply two numbers that are the same together. Keep it the same and go on to the next number and multiply them. So now I'm just going to end up multiplying 4 times 5, which is 20. So does 4 go into 20?
Yes.
Does 4 go into 20?
Yes.
Does 5 go into 20?
Yes.
You're good? We're okay? Okay, all right, just making sure. Now let me go back and put the problem back like it was originally. All right, so we have a 3 here and a 1 here. All right, what's the least common denominator? 12. All right, so my LCD is 12. The goal is to make sure all the bottoms or the denominators are the same. Okay, so I need to make sure that's a 12, this is a 12, and this is a 12. So on the bottom here I have a 4. What must I multiply 4 by to turn it into a 12?
3.
What you do on the bottom, you have to also do on the top. Alrighty, what do I multiply this 3 by for it to become a 12?
4.
Alrighty. What you do on the bottom, you also have to do on the top. And what must I multiply this 1 by for it to become a 12? 12. Alrighty. So multiply top and bottom by 12. Once you are done, guess what you can do? You don't need them anymore. Fractions are gone. It's just as legal as what we have on the screen up there. Don't I have the same thing that says step 2? Once you make all of the denominators the same, you don't need them anymore. You may delete them. Fractions all gone.
I was wondering. How you
Okay, so now usually what I also do here is I'll actually just scratch it out rather than erase it, because you're like, wait, I didn't write it all down yet. So I can put it back so you can write it just in case you hadn't written it yet. So let me put it so you can go back and write what you wanted if you hadn't written it all down yet. Okay, once all the denominators are the same, when I say the same, guys, you do understand I mean they equal the same value.
12.
Okay, so I should have a 12 here, 12 here, and a 12 here. As long as they all equal 12, you don't need them. So now we can scribble them out or delete them or erase them, however you want to get rid of them. What's left is now what we are going to work with. So, questions?
Wait, how did you get 3 on the outside?
This 3 right here,
Yeah, no, up there.
right here.
Yeah.
Whatever you do on the bottom, you must do on the top. So if you multiply the bottom by 3, you got to multiply the top by 3. Every single time, whatever you do on the bottom, you have to do on the top. Alrighty? So now I only want to deal with what's on top. What's on top? Tell me what's left on top. Okay, so do I distribute this 3 times everything in that parentheses? Okay, so 3 times 3 is? That's 9x minus equals
4x
plus
plus
Now the goal is still to solve and get x by itself. It doesn't matter whether you solve and get x on the left or on the right, whatever makes you happy. It doesn't matter. So I'm actually gonna get all the x's on the left side of the equation so that I can get x by itself. So I'm going to subtract 4x from both sides. Does that make sense?
Yes.
Okay. Subtract 4x from this side, from that side. And I end up with my 4x minus 4x canceling itself out. What's 9x minus 4x? 5x. And then I have my minus 6 equals 12. What should I do next? Add 6 to both sides. I end up with 5x is equal to what?
18.
Then what? Divide 5 on both sides. So x is equal to?
18 over 5.
And that is in simplified form. You cannot do anything. Do not turn it into a mixed number. Okay? So it's in the simplest form. There are no other numbers that divide into 18 and 5 evenly other than the number 1. So you're done. Did we get the same answer?
Yes.
Yes. Now, like I said, it's totally up to you. Whatever you're comfortable with, that's what you should do. Yes.
How did you decide which x to subtract from side?
It doesn't matter.
So you do 9x if you wanted to.
Correct. I could have subtracted 9x from both sides. My goal is I'm always looking to make my math easy as possible. So if that means it's going to stay positive, something's going to stay positive, I'm going to leave it. I'm going to do whatever math I got to do to get rid of fractions and negatives and whatever, anything that complicates my math. I'm going to do it. So I noticed that if I subtract 4 from both sides, ooh, this number stayed positive. However, had I subtracted 9 from both sides, it would have made this a negative over here. And I'm trying to eliminate places where I might make a mistake. But it wouldn't have mattered if you'd done it. It would have still given you the same answer. Questions? So, you okay with this method? Okay. Once you get all the denominators the same, you can get rid of them. Now, this works for solving equations, right? Now, you can't go and be like, well, Ms. Harris said if I have 2 fractions, I can always get rid of my denominators. If it's an equation that you're solving for x, but you can't just have 2 fractions. Let's say if you got 3/4 plus 7/9, and you be like, well, she said once it's 36, I can delete them. No, that's not what I said. When you have an equation that you are solving for, the variable could be an x or y, but you're solving for a variable, and it is an equation. In order for something to be called an equation, it has to have an equal sign. Okay, you can't just have 2 fractions on the board and be like, oh, I'm going to get rid of them denominators. You okay? You see what I'm saying? So just make sure you got an equation and you're solving for a variable. Alrighty, you're good? All right. Okay, so next slide. Here we go. Alrighty, here's one that's interesting. There's one step that we must perform before we can get rid of these denominators. Can you see that that's 1/2 times y over 2? We have to do that first. We have to go ahead and multiply those first. So when you multiply 1 times y, I get y, and 2 times 2, I end up with 4. Now can I go ahead and get rid of my denominators now?
Yes.
Yes. All right, what's my LCD?
20.
20, how'd you get that?
5 times 4.
Okay, so you did 5 times 4, and you said, well, 5 goes into 20, and then you said 4 goes into 20, and 20 goes into 20. So that's my LCD. I agree with you. Multiply 5 and 4, 20, 5 goes into 20, 4 goes into 20, 20 goes into 20. So I agree with you. LCD is 20. All of my denominators need to now become 20. What do I multiply 5 by to get 20? 4. What you do on the bottom, you got to do on the top. What do I multiply 4 by to get 20? Alrighty, and does 20 need to be multiplied by anything?
No.
It's already 20.
Then we can wipe out the bottom.
Then you can wipe out the bottom. Bottom gone. What's left?
4y minus 5y equals 7.
Done. See how much easier it is once you get rid of those fractions?
It's negative 1.
So 4 minus 5y is
Negative 1 more.
negative 1y, which equals 7. Can I leave my answer like this?
You have to.
Nope. So what should I divide both sides by?
Negative 1.
Divide both sides by negative 1. So y equals
Negative 7.
done. See, it's not so bad, is it? Questions?
I was struggling so bad last class with this. This is so easy. How you just did it.
Math is not, it's your friend. Math is your friend. You do it every single day. Even if you don't think you do it every single day. I don't care if you're buying food and groceries and gas and paying bills. You're doing it every single day. Okay, so here is the last part of this particular algebraic solving of the algebraic equations. In some cases, I'm going to tell you what one of the variables is, and then you just plug it in. So in this particular case, it says solve for x, which means get x by itself. And I'm going to tell you that y equals 2.704. So here's my equation, and I'm just going to replace that y with 2.704. So they gave you the y value, and they gave you an equation, and now all they want you to do is substitute for y the 2.704. Now can I solve and get x by itself? Yeah. What should I do to both sides right here at this step? Add 2.14 to both sides, which causes what to cancel out?
2.14.
This is going to disappear. And I'm going to go over here and add 2.14, which becomes 4.844. Divide both sides by,
1.384.
and you end up with 3.5. Questions? Okay, next part. All right, this next part just says remind you that when you are doing these problems in the homework or on the test, that sometimes that they will come with measurements. So if we're talking feet or yards or seconds or whatever it is, just make sure you note that sometimes in the homework it'll ask you for that particular measurement. So just look at the bottom of, usually in my math lab, it'll say in blue writing, make sure you include the measurements, or it'll tell you where to round your numbers to. So just look for that as well. And make sure your answer makes sense. So guys, when you put in an answer and it says the answer was, your answer turned out to be negative $55. Is there such thing as negative $55? Either you ain't got no money, you got some money. Right? Now, don't get me wrong. I know you be like, well, my account been in the negative. Mine too. So at the end of the day, is there any money in your account, even if it's negative? Is there any money in your account? No. Or let's even take it differently. If you're talking about feet, are there such thing as negative 5 feet? No. So if it don't make logical sense, change it so that it does make logical sense. Okay? We okay? Alrighty. So here is the next conversation. Alrighty. Is it hard for some people to pay off credit card debt in a reasonable period of time? And if that happens, is it because the interest rate is high?
Yes.
Okay, so the interest paid on $10,000 worth of debt over 3 years is approximated by the equation that you see. The function y equals 175.393x minus 116.287 in dollars. When the interest rate is X%, oh, yeah, let me make sure I read that right. It's approximated by when the interest rate is X%. What is the interest rate if the interest is $1,637.60? So let me make sure I've explained, because sometimes when you read, it don't make all sense. So you don't, but somebody owed $10,000 worth of credit card debt. When you pay credit card debt, they does not let you have the money for free, right? So usually it could be 10%, 15%, 25%, whatever the interest rate is. So you are paying interest on the money that they loaned you, right? Okay, so In this particular case, I want to make sure you understand what's the input and what's the output. Every time you get a situation, there's always going to be an input and an output. What's getting plugged in, what's coming out. So the conversation here is you have an interest rate, and it's going to determine how much money you're going to give them back in interest. Of course, you're going to pay them back the original amount of money you borrowed, right? But aren't you going to give them some extra money? That's called interest. It would be nice if they let me have some money and I just give them back what they gave me. But that's not how it works, right? So they want to know if the interest rate is a certain percent, how much interest did you pay them above what you already owed them? So you put in the interest rate, you get an interest amount out. So a percent goes in, and interest dollar amount comes out. Are you okay? You okay with the conversation? All right. Now look at the last question in the paragraph. It says, what is the interest rate if I paid $1,637.60 in interest? This is how much money, extra money I paid them over what I borrowed. They're asking a question. What is the interest rate? Are they asking you for an input value or an output value? Input. I want to know what the interest rate was that caused me to have to pay that $1,637.60. So, do you have an equation? You do. So if they give you an equation, you are going to have to use it. So in this particular case, they gave you an equation, and in the last question or sentence, they will give you another piece of information for you to use it. So, did they give you a y value or an x value here? A y value, because the x values are percents. So again, if they give you a y, plug the y into your equation that they gave you. You okay with that? Always, they're going to give you enough information for you to have an equation and some number that's going to be plugged in. But it's got to go into your equation. So here's my equation. Y equals 175.393, x minus 116.287. I replace the y with, that's how much interest money we paid. And so now can I solve and get x by itself? Yes. What should I do to both sides? Add 116.287 to both sides, which causes this to disappear, and add the 116 over here. You end up with 1,753.887. What now? Divide both sides by 175.393. X equals 9.9998. What was the interest rate you paid? 10%. Approximately 10% was the interest that you paid. The percentage of interest rate that you actually paid on the money that you gave them back. Questions? Does that make sense? Does this happen every day? Every day that you use your credit card? Or you may have got a loan from the bank for whatever. You got some student loans, do you? Are they letting you have that money for free? Well, let me rephrase that. If you ended up on, like, maybe you had a GI Bill or you're on a scholarship. If you're on a scholarship, then yours is free. You're on whatever the Hope Scholarship or whatever the different scholarships, then yours was free. Mine wasn't free. So, okay. So, am I paying back interest? Yes, I am. Okay, questions? You're good? Okay, alrighty. Alrighty, so we've got a few more things I want to make sure I cover before I stop. Alright, so here is the next section of this particular topic. We want to find something called the zeros of a function. It really means you want to find out what makes the y equal 0. What value of x makes the y equal to 0? That's what we're calling. So when it says, can you find a 0? It just wants to know what number for x makes the y equal to 0. That's what all of that says. And there are 3 different words for zeros that you'll see. And they've actually been here, and you'll see them highlighted in the next slide as well. It says 3 different concepts numerically mean the same thing. X-intercepts, zeros, and solutions all mean the same thing. So if I ask you for the 0, if I ask you for the solution, and if I ask you for the x-intercept, I mean the same thing. I want you to give me the same thing. We got it? Okay, so here is the next slide. Alrighty, so for the function f of x is equal to 14x minus 56, it says find f of 4. And notice in parts B, C, and D, it asks you for the 0, the x-intercept, and then the solution, which all mean the same thing. So for f of 4, what are you supposed to do when you see f of anything? Plug it in. Where are you going to plug it in at? The original equation or function that you're given. So you're going to plug in a 4 everywhere there's an x. Okay. So if we do the math, that's going to be 4 times 14. How much is that? 56. And what's 56 minus 56? Aha. So what number did we plug in that caused the whole function to equal 0? 4. So x is the 0. I know it sounds funny to say x is the 0 because you know x is not a 0. That's just the actual mathematical statement for how you say that. If it says find the 0, it just means find the number that causes the equation to equal 0. And what was that number in this case? 4. So if you plug in a 4, does the whole thing equal 0? Yes. So part B, we're going to do the same thing. It says, can I replace y with f of x here? Can I replace the f of x with a y? Yes. It's still saying the same thing. So I made a note here. F of x is the same as y. So it doesn't matter whether I call it f of x or I call it y. It's still what makes y equal to 0. What makes f of x equal to 0? And that's when x equals 4. Well, could I have just graphed that? Could I have graphed the original equation in Desmos? Well, let me rephrase the question. What's the x-intercept? Where the line crosses the x-axis. Could I have just typed that original equation in Desmos and looked and see where it crossed the x-axis at? I sure could have. And that would have still given me the same answer. So if we go to Desmos and type it in so you can see it for yourself. 14x minus 56. Aha. Look where the point, it clicked the point right there. There's my 0. When x is 4, y is 0. So we literally could have just went straight to Desmos and typed the equation in and it would have told us where the 0. We're looking to see where it crossed the x-axis. Okay? Questions? Alrighty, so with that, back to this one again. Alrighty, so then we just did the x-intercept using the graphing tool. The solution to finding it manually, here's how we would find it manually. So on every single test that I've given with this particular type of a question, it'll say, find the 0, and guess what y'all do? So here's my equation. I'm just gonna write it just like I see here. And on a test, it might have that question. And I say, find the 0. Guess what happens? Y'all plug in a 0. Every single time. 1, 2, 3, 4. It just sounds right, doesn't it? I know it sounds right, but you can't plug in a 0. You have to set the equation equal to 0. Because we want to know what makes the y equal to 0. So you just set the equation equal to 0. Now we solve and get x by itself. So I'm going to add 56 to both sides. The 56s are going to cancel, and I end up with 14x equals 56. Divide both sides by 14. X equals 4. So this is how you solve it algebraically. So if I say find a 0, are you going to plug in a 0? No, you are not. You're going to set the equation equal to 0 and then solve and get x by itself. Is that good?
Yes.
Okay, I'm trying to see what else. Okay, again, I just showed you how to do it in Desmos. The 3 words that mean the same thing, intercept, x-intercept, solution, and 0. You did look to see where it crossed the x-axis, didn't you? Okay. Does that look familiar? Does that equation look familiar?
Yes. That's what you
And it does look familiar, doesn't it? So there are two ways that you can actually solve this particular. We did it manually. For testing purposes, you need to know how to do it manually. So for example, if you were taking a test at home and you're like, well, I just typed it in Desmos and it gave me the answer. And if I say I need you to do it manually, then I would want you to work it out like we worked it out right here and bring that back to me on the scratch paper. Even though you may have still used Desmos, I still want to see this on your scratch paper. Okay? Alrighty. So to do this one, we have a couple of options. We can type each side of the equation in Desmos first and see where they cross. So let's go do that. Actually type what's on the left side of the equal sign, type it in Desmos by itself, come down another empty space and type x over 3 plus 1 in another slot. Do you guys know how to create the fraction in Desmos? Literally just hit the slash or the division symbol. It'll create a fraction for you. You should end up with 2 lines on the screen. I'm just showing you the first method. It's not showing it to you on that particular slide. You should get 2 lines on your screen. Do you? Once you type both equations, you should have 2 lines on your screen. You got it? Okay. Let me type it up there so y'all can see, just in case everybody doesn't have it quite yet. All right. What was the first equation? 2x. What did I just do? Wait a minute. 2x minus 3. Yeah, see, if I do it that way, it won't write it right. Division. Okay, I don't know what I was hitting that was doing it wrong for some reason. Y equals x divided by 3 plus 1. Plus 1 or minus 1? There are your 2 equations. Did you have these 2 equations on your screen? Wherever they cross is the solution. So, what value am I looking for, the x or the y? Remember, you were solving for what letter of the alphabet? What variable were you solving for in the original equation? Did you see a y anywhere? No. So you were solving for x. So what is the x value? That's the solution. 10.5. You mean I could have done that whole other problem that I had on the board here this way? Yeah. The only difference is Desmos will not give you a decimal, will not give you a fraction. So you see how it wrote the answer in decimal form? Notice the answer we got when we did this problem.
You can't look it up.
You could reverse, you could do it, but it will not give you 18 over 5. So sometimes in my math lab, it won't take it written as a decimal, it wants the fraction form. So if you're like, well, I put the answer in and I know it's 10.5, it wants it in simplified fraction, and it'll usually say, I want the answer as a simplified fraction. That means you can't put a decimal in, even though you know it's right, you still can't put it in. The calculator will reverse. If y'all had a calculator have the S to D button, it'll switch it from one to the other. All righty, questions? All righty, so you got that part. The other part is if you actually set it up like this, and I'm going to go ahead and type it in since I'm in here. Let me put my equal sign and retype this the way I want it with the 3. Whenever you don't type something right, you do know you're going to get this big yellow exclamation mark, right? All right, so I'm going to get rid of this because it doesn't like 2 equal signs in there. Notice, if you take both equations and put them in there together just like it was originally written, it gives you the answer right there. So you have two different methods of how you could do that, as well as doing it algebraically by hand. Mm-hmm. We just solving for x. Because remember, we were trying to figure out what's going to make y equal to, look up here on the screen, what's going to make y equal to 0. What x value makes the y 0? 10.5. Questions? All righty. And let me see how much more of this I want to see if we're, all righty, so we just said that. I just showed you how to do both of what we just wrote on the screen here. So again, of course, you can put the left side in the Desmos and then go down to the next line and put the right side in and see where they cross. We just did that. All right, last one and then we'll stop. Okay. Let's see if we can understand the conversation here. The function y equals 0.55x minus 2.86 describes the average time, which we're calling y, served in prison for a crime as a function of the average sentence length, x, where x and y are each measured in months. Okay? So now make sure you understand the conversation. What are we talking about? Okay. Okay, so if you go to the judge and the judge says you are sentenced to 10 years, do you serve 10? Sometimes, sometimes not. So this is saying if you get 10 years, what's the average amount that you actually serve? You see what I'm asking you? Say you might get 10 and serve 5. You might get 20 and serve 10. So the question is, if you were sentenced to 10, how much? And they're saying we can use this equation to determine how much you actually will serve, or approximately how much you might serve. Does that make sense? Yeah. Okay. All righty. So, and it's telling you that this is in months, so kind of keep that in mind. All right, so it says to find the sentence length, right? The sentence is what the judge told you were going to be sentenced to. Okay, the sentence length for a crime that would give an expected time served of 10 years. So you were expected to serve 10 years. Let's see if I read that right. To find the sentence length for you expect this, okay. Write an equation and solve it by using the X-Intercept method and the intersection method. All righty, so note that 10 years is 120 months. We want to solve the linear equation where 120 months is equal to this. Remember, what was y again? I want to make sure you understand the difference between y and x. The average time that you actually served, and x is the sentenced amount. Okay, so let's make sure. What did they give us in this particular sentence to find the sentence length for a crime that would give an expected time served of 10 years? So we don't know the sentence amount that the judge sentenced them to, but they actually served 10 years. So how much were they actually sentenced to? That's what we're trying to find out. So, did they give us an equation? Okay, are we going to use it? Yes. And what else did they give us? How much they actually served. So, remember, X is the what in this particular conversation? X is the sentence amount, and the Y is the actual time served. So in the last part of did they give us the actual time served, or did they give us the sentence amount? Look over here, it's time served. The expected time served was 10 years. So they gave us time served. Is that the X or the Y? Okay, so I'm making sure we're on the same page. X is the amount that the judge told you was going to serve. And the Y is the amount you actually went ahead and expected to serve. Does that make sense? Okay. All right, so in the place of the Y, I'm going to put 10 years, but instead of 10 years, I'm going to turn it into 120 months. How do you get 120 months? 10 times 12 is 120 months. So they actually served 120 months, but I want to know what the judge sentenced them to. So now can I solve and get X by itself? Alrighty, there we are. So, what did we do? What did I do to both sides?
You subtracted 120.
I actually, in this particular case, it used it where it subtracted 120 from both sides.
How come you didn't just move 2.886 to the?
Because when I pulled this slide up, that's originally how it was set up, but you're right, I wouldn't have solved it that way. Some of these slides, when I pull them together, I pull information. Again, all this information comes from the book. And sometimes I don't agree the way it's set up, and I didn't change that one, but I will change that one. Because here's how, let me go back to the previous slide. Here's how it's set up, and so let's see what I would have done. All right, so tell me what you're saying I should have done. What should we have done, guys?
Add 2.886 on both sides.
Right. Is it wrong how the original book did it?
No.
No, it's not. So we will add 2.886 to both sides. Whoops. And what did we get?
122.886.
Okay, so we ended up with 120 plus 2.886. We ended up with 122.886. Divide both sides by?
0.55.
So x is equal to, somebody do that on the calculator. What'd you get?
223.
Okay. So, did you get 223?
Yes.
Okay, so once you do it in the calculator, you should get x is equal to 223. And this is 223 what? Months. Alrighty, so what is that? Again, if this prisoner receives a 223-month sentence, we would expect he or she served what? 120 months, 10 years. So they kind of serve half the time? Okay?
Yeah, almost.
Similar to, okay, questions? So can you guys see how I'm just using anything and everything that you've seen stuff? I mean, I never paid any attention to people getting sentenced and how much time they actually might serve. But now you can see how this is so relevant. Somebody's doing this math. Where do we think we got this from? I mean, the key is that do we have prisoners in the prison system? Yes. Do they actually serve time? Yes. Do they get sentenced a certain amount of time? Yes. So all we did was take that data and put it into a tool and create an equation from it. And boom, here we are. So now if you know somebody that gets sentenced to something, you can be like, well, you probably only gonna serve 5. You know, you can do the math. You can do the math and tell them, well, you probably only gonna serve 2. Okay? Questions? All right, that's enough for today. So we almost finished with 2.1. We'll finish 2.1 when you come back. And I will have decided what test information you'll need. Let me go ahead and press the stop button so it'll stop me.